I'm sure you've seen these things before, or variations of them. It's a game cart, obviously, for either the original Game Boy or the Game Boy Advance, except it's 100% not supposed to exist. These carts are completely unofficial and just full of pirate games. The kind of thing your well-meaning gran would buy from a guy in the market for 20 quid because, what a value, look at all these games you get. If you seek out games to collect, you'll either like these things as some sort of weird curiosity, or you'll actively try to get rid of them. And if you've played one, well, you'll notice the games are a little bit strange. There's lots of copies of the same game, often repeated. Some of them you've heard of, but then there's weird ROM hacks. And these strange, just odd, like random games that literally you've never heard of in your life. And it's these weird games that kind of got me thinking, can I make a game this bad? Let me explain. So I have grand ideas of making my own roguelike, using my own game engine that I'm making from scratch, and it's kind of taking me a while. You know, because I'm literally making it from scratch. For some obscure 8-bit inspired retro computer that's really two microcontrollers stuck together with like a serial link in between, pretending to be a modern recreation of a BBC Micro from the 80s. I don't know why I do this to myself, but you know, it keeps me entertained at least. This roguelike game will never appear if I just try to make it. There's too many parts that I need to write, and if I try to plan and guess what I think I'll need, I'll end up making some clever system that's completely and utterly useless, full of unwanted features that everybody thinks you need to put in a game engine, but you don't actually need to do. I need to build the tech first, but the tech needs a purpose. And I figure I might as well do it one game at a time, with each successive game giving me a reason to add missing functionality. And these pirate carts remind me, in the same way shareware from the 90s does, that games don't need to be polished AAA wannabe masterpieces. They can just be a thing that's fun to play, even if only for 5 minutes. Those weird cartridges I've just shown you, the games on them were written by actual people. Or at least someone bothered to spend a bit of time hacking ROMs of existing games. They probably wanted to do it for fun. Games like whatever this thing is trying to be. Someone did this on purpose. If you've not figured it out, writing a game is hard. It's time consuming. You've got to be committed, both to the process and possibly to a place that gives out free grippy socks and has calming blue rubber walls afterwards. They're not just something you can mash out in an evening without some sort of plan. I'm going to make my own rubbish games. Each one will add a new feature to my engine, so I've got a purpose for adding new features, and I'm not just making things up as I go along completely. Don't be confused, I'm not deliberately trying to make poor quality shovelware. This isn't the early 2000s, I'm not a contract programmer, charged with making GBA games as fast as possible so I can afford to eat next week. The poor quality will just sort of naturally occur through the process. I will actually be trying to make something as good as I'm able to, but I've only got certain limitations with my ability to produce creative things. The features I add will gradually build towards enough code that I can actually make this roguelike thing that I want to actually make. And by then I might have figured out what it is and I might stop calling it a roguelike thing. And I'm starting by turning this into this. And I think I'm going to choose this as my hello world of game dev now. Every new system or platform I write games on will have this game as a test game just so I can figure out what's going on. And here's how I made it. So my current game engine can do the following things. It can draw rectangles. It can move them around using simple velocity calculations. It can take user inputs, and then it can do collision detection and some limited collision response. And that's it. However, with this small collection of features, we can actually make a game. Here's the basic starting idea for the game. There's a falling good item. I have no idea what to call this thing, so we'll just call it a good thing. And if you collect it, you earn a point. So that little magenta thing at the bottom of the screen is you. And you can move left and right between 3 things that I'm calling tracks. It's not that amazing, but it's kind of the general concept. Let's see how we can improve this. If you've ever played any game before, and I'm kind of assuming you have done, there's a lot of extra parts around the gameplay that you simply take for granted and you probably don't notice. Like in a game, it needs a title screen. Something has to appear when you open the game up for the first time. It doesn't just begin. And you have to be able to get back to that place when the game has ended. And in fact, the game stops at some point. Either you win it, or you run out of stuff to do, or you die. I need to add all those tiny little pieces. I have an event system in my game engine, and wiring up a basic game loop was reasonably straightforward. I have an enum of event types that contain various events that can happen in the game, like an entity becoming dead, colliding, going off the screen, or the level being complete. There's an event struct. This is passed between the code emitting an event and the handler processing that event. There's a little bit of funky union of structs to pass the required data to the handler. You'll see quite a bit of this in my code where my stubborn insistence in using C on some low-powered microcontroller makes me pretty much reinvent C++ features. There's a behavior component that gets added to entities that need to run code. Here's how the good falling entity works. I split the code out into its own mini state machine. So we now have state machines inside state machines like some sort of Inception-based mess. However, it is really just a cleaner way of writing code and is functionally identical to a bunch of nested if statements. When the entity drops off the bottom of the screen, it switches state to being dead. And then it fires off an event to tell anyone listening it's just died. This event is used over in the main game state, where the actual game logic lives. In game init, the event is subscribed to and connected to a handler called on-off-bottom, which makes zero sense but is kinda logical because, naming things sensibly gets a little bit difficult at times. In that callback, I work out if the entity that fell off the screen is a good one, and if it is, I fire off a game over event, which needs its own callback. You thought having state machines in state machines was getting complex, and now have events causing other events to happen. It is actually fine though, because any new events won't be processed until the next frame. So it's not like if I was firing off hardware interrupts from inside interrupt handlers and kind of deadlocking the CPU or something. This callback decides if the game has been won or not, and behind the scenes causes the entire game engine to just reset itself. Part of this required me to remove code from the main C file and put it into the game state file for the main game loop. This kind of coding that I'm doing now is really tidying things up. It's forcing me to put sections of code where they actually belong. And here's the end result. It looks exactly the same as before, which is a bit tedious to be honest with you, because here I am showing you yet another exciting screen of a block moving towards another block. This is grade A, front page of Steam stuff, surely. However, behind the scenes is where all the interesting things have been going on. And that's kind of why you're here anyway. So the next thing to do is increase the challenge by speeding up the falling thing. Sometimes what seems like an easy task turns into an epic side quest that results in extra functionality you didn't even know was needed. Take, for example, the simple task of making the game speed up when a certain score is reached. It sounds like a super simple thing really. You have some sort of speed variable and you just make it bigger. The code that makes the item fall just needs to read the score and update the item's speed. Except, no, this isn't a good idea. I'm trying to keep this code from turning into spaghetti. I've got this sacred idea of an entity component system that I'm fully buying into. Nothing is connected directly like that. I spent a long time in previous videos carefully cutting up the engine into different components and systems and telling you how good this was as an idea. Everything is clearly separated. So I tried to use my existing code, but I got stuck. So I had to stop and have a bit of a think about what to do next. I thought I could do this just by editing my existing code, but it soon became a mess and I discovered it was pretty much impossible to have an entity know when to speed up. You see, this is an entity component system. There aren't entities as such. There's no init logic that gets run when the entity starts up. And unless I wanted a specific falling block init component, I had no way to communicate the new speed to a newly created entity. I've kind of programmed myself not into a corner, but more I just can't directly communicate with things, and that's by design. So I need to find a better way. I decided, with some mild AI assistance, to have a central registry of default values for components, and then a way to set and get these default values from inside the main loop of the game logic. That way it's the game logic that's driving everything, because that's the thing that knows what scores are and what level should be next. And it's up to the game logic to tell the components what values they should contain when they first start up. It's not up to the components to figure it out themselves or to reference global stuff. I'm calling it an archetype system. It's possibly the same as a prototype pattern from the design patterns book, but to me, a prototype means a test version of something. This is more like a set of default values for the component structs that I can copy into the components array. It's important to pick names that make sense to you. I've got a website. It uses a static site generator called Hugo. You write content using Markdown. Then Hugo makes it look nice using HTML and CSS. In Hugo, to make that happen, you've got templates, and then things that it calls archetypes, which define the actual structure of the Markdown. So to me, and kind of where I nicked it from Hugo, is that a template is a whole thing, and an archetype is the default starting point for an instance of that thing. And talking of websites, you nearly clicked off thinking this was a sponsored section, didn't you? It isn't. My website is another good place to go if you're curious about what I do between videos. It takes a lot of effort to make a video, and there's things that I do in the background that either don't make it into a video, or I just don't think are good enough to have a video made about them. So I stick it on my blog, and I put a few photos in. Another place is my Patreon. I've got a free tier, and I put similar things in there. It's just like a place to go, rather than hoping that the algorithm chooses to show you this stuff again. Which also is your reminder to press subscribe if you watch this far, because chances are you'll probably want to see more of what I'm doing. The archetype system is kinda clever. It starts with this slightly odd struct, which contains an array of void pointers, one for each component in the system. This is then put into an array, one entry per entity type. You know you're in strange territory when void pointers are being used. Welcome to programming an embedded system. Just how much can I squeeze into a Z80 CPU on steroids? The array contains one of those for each entity type in the system. It's a way of storing instances of each component that I can then copy over the ones being used by a particular entity when it's created. This struct is the archetype table. Don't think too hard, I'll explain it more. Don't worry, it's a little bit obtuse, but we'll get there. I have something called a component registry. It contains a component info struct that holds nothing but a size T. To be honest, the struct is probably redundant, it might go away in the future. These get stored in an array, one per component. Then there's an initializer that sets each entry in the array to be the size of the component it references. This does nothing more than record how big each component struct is in memory. We're using void pointers, we need to know how big they're supposed to be. Because yes, this is yet more C programmer reinventing C++ features kind of things. Inside the entity manager is a register function, into which you pass various functions. One is the prototype function. Its job is to construct all the components for an entity. This is what the proto function looks like for the good falling thing. The code is a little bit weird, because this is C, and again, we're beating it into being more like C++, but all that's really happening is a new instance of each struct is being created, and then copied into the archetype table from before, using the rather nasty setArchetype macro. When an entity is created by the game, an ID is found for it. The components are composed, and then the create function for the entity is used. The compose function contains a memcopy that references the archetypes table. This memcopy is the whole trick. I've got an array of component structs with default values, and all that's happening is they're getting copied over the values in the actual component array. The end result is that in the game state's collision callback, if we collided with a good falling piece, and the score is divisible by 3, the game speed can be increased. And then, the velocity component stored in the archetype table can be retrieved, and its speed value altered. Now, any future entities that have a velocity component will have the new updated speed to use. Saying this, I can't figure out whether it's a well-engineered bit of code that can be easily expanded, or an over-engineered bit of code that's going to turn into spaghetti later. You know, I've developed this attitude that if it's worth engineering, it's worth over-engineering. I'm in this constant state of trying to write as little code as possible, while also trying not to program myself into a corner I can't get out of. It's recognizing when I need to add new functionality, or just use the stuff I've actually built better. Either way, currently it works, as we're about to see. This is looking more game-like already. It's only a tiny little tweak that we've done, but games go through quite an interesting phase where they stop being tech demos and actually become playable and a bit distracting. We've got to that part, it's playable, but it's just not quite there. It's a little bit boring to play after about 2 seconds. There's literally no challenge. I'm either collecting the falling thing, or I'm just staying still. And I need to be interacting with this game all the time. If there's any point where the player just doesn't have to do anything, they're going to get bored and stop. The difficulty increases with time, but I need a secondary challenge. Like a thing to avoid, because that'll add an extra bit of stress to the player. They can no longer simply react to a moving object and move the player underneath it as fast as possible. They'll now have to process what object it is and decide if they should move and catch it or move and avoid it. I'll spare you the details of exactly how I did this, because it was actually quite easy. All I did was I copied the code for the good falling entity, changed it a little bit, and modified the collision callbacks to check if the collision was for the falling bad item. It did take about 10 minutes to do, and that was it. It was a good hint that my game engine was designed quite well. So here it is, the final playable version of the game. And here we are, a more complete game. I'm stopping here, or I'll just end up endlessly polishing something that's reached the end of its usefulness. I've learnt all I can from this game. I need to move on, make a new one. But there are certain things about this game that I quite enjoyed doing. Weird things like it's now got a nice little title screen. It actually looks like something. If I got someone random to play this game, they'd understand it was a game, not just some random blocks dropping down the screen. And these little finishing touches, like the title screen and a bit of colour and a better looking game screen, was actually fun to do. I've spent so long making infrastructure that's just mind-bogglingly difficult to comprehend that choosing what colour to make the title text and what screen coordinates the high score should be was a nice little mental diversion. I quite like that part of game design. And hopefully, as the engine gets more complete, I can spend more time designing the game and being creative in what I've made, and less time hunting down weird obscure bugs buried in obtuse C code that I wrote whilst trying to figure out what I'm doing in the first place. Although I like that kind of problem solving as well, and I think you quite like watching it, so I'm not going to stop that bit, but you might see a little bit more game design things as well as I get to play in the thing I've created. So let's briefly look at what went well and what I could have done better at. To be honest, I'm pretty happy I actually got this finished. I finished a thing. This isn't my first game I've ever made. I used to do this thing called the 1 Game a Month Challenge way back in 2015. This website gave you a prompt and you had a month to make a game. It was pretty good fun. I got into like a nice routine of making stuff. And it didn't take me 6 months. This one took ages because I had to build all the stuff behind it. But I didn't need to write an entire engine to make this game functional. I wrote enough to make the game work. It's also taught me the importance of making complete things. I think a lot of time we make something, it gets to a point where it starts to get a bit difficult and we give up and we move on to the next shiny distraction. A few moving sprites on a screen is not a game. You really do need all the rest. It needs to be a complete thing with a menu and a bit of title screen. It doesn't feel amazing art or anything, but the whole experience should feel like a game. It looks better when you show it people. There's also a limit to how much you can actually plan. I'm sure there's an experience thing in this and that fun gameplay you can deliberately plan it, but you probably need to make a lot of bad games first. Just like you need to make a lot of bad videos before you figure out how to make a half decent one. But I'm going to continue making crappy games to test and expand my engine. I like doing the process. They'll make it into future videos. Either maybe it's how I made the video from start to end, or bits of a game that help me explain something I'm doing in some other programming. I'm not going to turn into a game dev channel, but there may be game dev stuff happening. Next time, I'm going to add a tile map to the game. This will unlock more interesting game styles. You can do a lot with a tile map. It's why they existed in the Game Boy. Mario would be really boring with just a black ZX Spectrum style background. Also, the Agon Light development system has been updated to include specific support for tile maps. So I no longer need to manually draw bitmaps on the screen, which will save a lot of time both for me and the CPU. Might be able to get a screen that scrolls neatly without lots of awkward hacks that don't really make it work in a game. So come back next time where we're looking at tile maps and whatever else I get distracted with on my way to making tile maps. So I'll see you then. Much more interested in figuring out how the Agon actually does that. So I'm repeating myself now because I've already written that. Oh, for fuck's sake. Let's balls. It's like 5 lines and I keep... 13, outro.